Welcome back to the video series on integration and differential equations. Today we're going to have a look at integration by parts. There are two main methods for doing integration by parts. The first one is the tabular method, or some people might call that the table method, and the other method is the formal method. So in this first video we're going to look at the tabular method. Let's try an example. Let's evaluate the integral of x cubed times sine x with respect to x. To set up an integration by parts problem, we want to split the integrand into two factors. So here's our integrand here, x cubed sine x, and let's consider the two factors to be x cubed and sine x. So what we're going to do is set up a table. We'll have two columns. First column will be called D, and that stands for differentiate. Second column, I, for integrate. And we're going to put our two factors into the two columns here. So let's put x cubed in the differentiate column, sine x in the integrate column. Okay, now the idea is that we're going to take derivatives of x cubed until we reach derivative equals 0. Starting with x cubed, our derivatives will be 3x squared, 6x, 6, and then derivative of 6 is 0. So we've just gone through and successively taken derivatives there. We successively taken derivatives, you could say. All right, now moving over to the integration column, we've got sine x. So we're going to go through and integrate step by step. Remember that the integral of sine x gives you negative cos x. And then when we integrate cos x, there's no sign change. So it's going to remain negative now, negative sine x. When we integrate this, there will be a sign change. We're now up to positive cos x, and then integrating that positive sine x. So we've gone through and successively integrated these different terms here. Great, so that's our table. Now, before we go on with the process, let's ask a quick question here. So let's see what would have happened if we had reversed the factors, meaning if when we set up this table, what if we had put sine x in the D column and x cubed in the integration column? Okay, well, if we started with sine x, we took some derivatives, we get cos x, we get negative sine x, etc. And as we continue this, we would never reach derivative equals 0. And what that's telling us is that the tabular method does not work. So now we have a bit of a fuller understanding as to why we had to set the table up the way we did originally. We want x cubed in the differentiate column so that we will eventually reach this derivative equal to 0. And if we had accidentally set it up the other way, then after a little bit of thinking we would have realized, no, putting the sine x in the D column, that's not going to work. So then we could cross that out and say, okay, let's go back to our original approach then. So at this point we've set up our two columns and we understand why x cubed goes in the D column, because that's eventually going to produce a derivative equals 0. So that's great. So now we're going to finish our calculation. So two more things we need to do. We need to form diagonal products in our table, and we need to deal with the signs. So the signs are going to alternate plus, minus, plus, etc. So let's see how that looks in our table. So going back to our table over here, we're going to form diagonal products going from the upper left down to the bottom right. So we're going to be multiplying these two guys together, multiplying these two, these two, and these two. And the signs are going to alternate: plus, minus, plus, and however many rows you've got in that table, you're just going to alternate your signs all the way down. All right, so what this expression in the table is giving us is actually the value of the integral that we're trying to find. So the integral of x cubed sine x dx, we're going to be able to read it off the table. And in looking at the signs over here, the way I interpret this is a plus sign means no sign change, whereas a minus sign means a sign change. So if we look at our first factor, we've got x cubed times negative cos x, and there's no sign change associated with that. So that's going to come out to negative x cubed cos x. Okay, and then going to our next term, we've got 3x squared times negative sine x, and there's a sign change as well. So overall that's coming out positive plus 3x squared sine x. Okay, and then continuing down, we've got positive 6x times cos x. So let's write plus 6x cos x. And then finally minus 6 sine x. Okay, and the table or tabular method is a little bit of a shortcut. We are going to have to remember conceptually that we're going to need a plus c at the end of this expression. So here's our calculation from the previous screen, and just as an aside to finish up our video, let's make sure we could handle a definite integral. So suppose we wanted to integrate from 0 to pi, and we wanted to integrate that same quantity, x cubed sine x dx. Well, if we were facing a definite integral, we would go through the tabular method just like we did in the first example, and we would have found our antiderivative to be minus x cubed cos x plus 3x squared sine x. So I'm just recopying this expression from what we found on the previous screen. It was plus 6x cos x minus 6 sine x. All right, so that looks like we copied that correctly. Now, the two differences with the definite integral, remember we don't have the plus c on there, so I didn't copy that down. And what we will do is evaluate this whole expression at pi and at 0. So let's just remind ourselves before we plug in here, cos of pi is going to be -1. Sine of pi is going to be 0, and sine of 0 also 0. So it might be handy to have those quantities sitting in front of us before we do our plugging in. All right, so here we go. Let's plug in. Plugging in pi, we're going to have minus pi cubed times -1. So overall, positive pi cubed. When we get to the sine term here, sine of pi is going to be 0. Then we've got 6 plus 6 pi times -1, so that's minus 6 pi. And then again, this sine x term is going to be 0 when we plug in pi. All right, so from plugging in pi, we've got pi cubed minus 6 pi, and then we're going to subtract off what we get when we plug in 0. All right, so plugging 0 all the way through here, all these polynomial terms, all the terms that have polynomials in them or powers of x in them, those will all be 0 thanks to the x's. And then when we get to this last term here, sine of 0 is 0. So in fact, that whole expression is 0. And there we have our final answer. It's going to be pi cubed minus 6 pi. So the tabular method will let you handle both indefinite and definite integrals just through that same approach.